Hi guys, I'm Jahnavi from EC. Hope everyone is doing well. The topic which we are going to discuss now is pneumatics. I know many of you might be hearing this term for the first time because I was in the same situation few days back, so don't worry, you'll get to know what is it by the end of this session. It's really interesting topic, so please pay attention and let's get started. Pneumatics. Uh, First, let's list out the things which we are going to discuss in this session. First, what is pneumatics? What is air pressure? Pascal's law, pneumatic system and its components, directional control valve, why pneumatics. Let's start with the first one, which is what is pneumatics? Pneumatics is the branch of physics that deals with mechanical properties of compressed gases. You might be thinking what? Do gases have mechanical properties? Yeah, gases do have mechanical properties. Not gases, compressed gases have mechanical properties. So you'll get to know how and all further in this session. So we mention compressed gases here, but we mostly use air because it's free and available everywhere. So air drives pneumatic systems and pressure is the driving force. Pneumatics is used in construction, factories, mills, and other areas of building and technology to speed up the workflow. One of the major field is construction. You know what is this, right? It's a bulldozer, and we have this thing is called pneumatic cylinder. This one and this one. We have 3 to 4 pneumatic cylinders in a bulldozer. So you can understand how this pneumatic cylinder works in further session. So what is air pressure? The force exerted on the surface by the air above it as gravity pulls it to the earth. For example, in this picture, if we consider this layer, then the force exerted by the air above it on this layer is called air pressure. And we can say that air pressure decreases as we go above. That is, if we consider this layer, the air is very less above it, so very less force will be applied on this layer. So the pressure decreases as we move up. Now the mathematical form is normal force per unit area, that is F by A. If we consider this surface, then the normal force or perpendicular force on this surface by area, that's called pressure, and it's measured using barometer. Let's see Pascal's law. Pressure applied at any point of the liquid in a container, usually a closed container, is transmitted to all other parts of the liquid without any loss. Now, if we take this round flask or container with some holes on it, and if we apply pressure on this piston, which is kept at opening end, so if you apply pressure on this, it's transmitted to all other parts of the liquid. So the fluid inside this flask will spill out through all the holes without any loss. This is mainly used in hydraulic lift, brakes, excavators, and jacks. The major principle is that it is used to produce huge force from smaller force, that you'll understand when we see an example. Let's see hydraulic lift. For example, if we consider a U-shaped container like this filled with a fluid, and U has 2 opening ends and those 2 are closed with 2 pistons, and each of area A1 and A2 where A2 is greater than A1. Now if we apply a pressure F1 on A1, if we apply a force F1 on A1, then gives a pressure of F1 by A1. We told that in a closed container, pressure is equally transmitted to all the parts, right? All the parts of that fluid. So we can say that same pressure is transmitted to this piston also. So the car gets lifted up by a force F2. The mathematical form of this is we told pressure is equal, so F1 by A1 equal to F2 by A2, and from this we can say F2 equal to F1 into A2 by A1. As A2 is greater than A1, so we can say that A2 by A1 is greater than 1. So obviously F2 is greater than F1. So by applying a small force, we can lift heavy objects, that is producing a huge force by just applying small forces. Now let's see pneumatic systems. Pneumatic system is just a system which is used in this mechanism pneumatics. So now let's list out the works which we have to do in pneumatics. That is, first we have to compress the air, then transport the air, then control the air, then use that air to do work. Now we'll see the components which we use to do this works. That is, for compressing air we use compressor, then we use pneumatic pipes for transporting air, and then we use valves for controlling air, and then we use pneumatic cylinders or actuators to do work. These are basic components. Now let's see the arrangement of a pneumatic system. This is the diagram. Now we have a compressor here. This is the symbol of compressor. We indicate it like this, or we just indicate it by a triangle, or remember this symbol because we are going to use it further. So this is the compressor, and next we have some small components which are used for filtering, lubrication, and like clear air from moisture and all. Now we have this things which are used to connect all components. These are called pneumatic pipes. We have many valves also, and we have double acting cylinder. It's one of the type in pneumatic cylinder. You'll understand what is it further. Next we'll discuss each of the components in detailed manner. The first one is compressor. This is how it looks. Let's see the definition of it now. As I told, it's used to capture and compress air. It converts the power of the motors into potential energy stored in compressed air. This is the motor. There are two ways of compressing. The first one is reduce the volume, that is called positive displacement. That is, air is taken into a chamber and it's compressed by reducing the volume. You know, right? If we reduce the volume, pressure increases. It is ideal gas equation from ideal gas equation. So we can say that is positive displacement. Now we have dynamic displacement, in which we speed up air to high velocity and then restrict the airflow. So then that leads to the increase in pressure. We mostly use positive displacement in many applications. Now let's see the working of compressor with an example. Let's see single stage compression. This is the compressor. We have many components in this. Let's see the working of it. This is the cylinder with piston, this one. Inside it look like this. If we have an inlet valve here through which the atmospheric air enters, and this is the shaft which will be rotating. The atmospheric air enters through this, and when this shaft rotates, the piston moves up and the air in this gets compressed, right? And we have an outlet here. That outlet gets open and the compressed air is collected through this pipe into this tank. Now in single stage compression, when we do this continuously, then the machine gets heated up and it may lead to some explosions and all. So to avoid this, we use multi-stage compression. In multi-stage compression, we have two cylinders with piston, and we have a tube here which is called cooling tube. So like first air enters through this, and as the shaft rotates, this piston moves up and air gets compressed and moves through outlet, and compressed air goes through this cooling tube. It gets cooled and then enters through the inlet of other cylinder, and then this piston moves up and air gets compressed, and then it's collected from this outlet again. I hope you get my point. This is how the compressor works. Now we'll see pneumatic pipes. Pneumatic pipes, as I told, they are used to transport air. That is the connection between all other components. We usually use a polyurethane tubing in pneumatic pipes because it's more resistant to damages. If you want to know more of its properties, you can refer other sources. This we are not going to discuss here. These are some of the pictures of pneumatic pipes. Next, let's see pneumatic valves. Pneumatic valves are just like switches, and we use switches to control the current flow. Similarly, we use valves to control or modulate the flow of air. Usually, they are controlled by pneumatic, hydraulic, electrical, or mechanical actuators. And we have two types in this. One is flow control valve, which is used to control the rate of flow, and next we have directional control valve, which is used to control the direction of flow. These two pictures are flow control valves. This just works like tap. We have this rotating thing here. When we rotate, by rotating it, we can increase or decrease the rate of flow. Similar like taps only we use. Like if we rotate the tap, we can increase, decrease, and off the tap also. This works like that. Next, and directional control valves we'll see at the end of the session, because for understanding that better, we need pneumatic cylinders or actuators also. So first we'll see that pneumatic cylinders or actuators. This is the diagram of pneumatic cylinder. These are the mechanical devices which use power of compressed gas to produce the force in reciprocating linear motion. Reciprocating linear motion just means up and down or back and forth linear motion. That is like this, like it goes. If we apply pressure in this compressed gas, then the piston moves that side, and when we apply compressed gas from that side, then the piston comes back like this. Yeah, that's back and forth motion. That's why it's called reciprocating linear motion. Now we have types for linear motion. We have single acting cylinder, double acting cylinder, multi-stage or telescoping, both are same. Next we have rodless cylinder. There are two more types also, like rotatory and semi-rotatory, which we are not going to discuss in this session. Now let's see the first one, which is single acting cylinder. Single acting cylinder just has a piston. This one is the piston, and this is the rod, and we have a spring, and we have an inlet port. When we pass compressed gas through it, the piston gets extended, and through the spring force it comes back. But in double acting cylinders we don't have any spring. We have two ports. So when we pass gas through this, compressed gas through this, then it gets extended, and when we pass through this, it comes back. This is how these cylinders work. Now telescoping cylinder. or telescopic cylinder. This cylinder is mainly used when we need long stroke. But as this cylinder, like if we make it a long stroke, then it becomes thin, right? So this is used when we need minimal loading. For heavy weights, this can't be used. You can clearly understand from this, when we pass compressed gas through this, stroke by stroke gets extended and it becomes long. You can see it looks like this in complete extension, and it looks like this before extension. Now we have rodless cylinders. As the name suggests, these cylinders don't have any rod. It just have a long piston, and it has a slider also. This piston and slider are usually should be attached together. So they are usually attached mechanically or using magnets or whatever mechanism we can do. So the working of pneumatic rodless cylinders is like this. It looks like this. This is the cylinder. We have a piston inside it, and this is the slide bar. And we can use it for watering this piece of metal. Now we'll see directional control valves. This is really important, so please listen carefully. We have directional control valves to control the direction of flow. They are named as A by B valve, where A indicates the number of ports and B indicates the number of switching positions. We'll understand it further, what is ports, what is switching positions and all. The graphical representation is like this. This is the directional control valve. Here we have two squares, right? This one and this one. This number of squares indicates number of switching position, and we have this arrow. This represents the direction of flow, and we have we have this port. One is called pressure port, that is through which we supply compressed air, and we have two exhaust ports through which the air will exit, and we have this thing. This I told, right, valves are usually controlled by actuation. So the actuation symbols are indicated either on a right side or left side. This is the spring return. Spring return just means that, like, if you on the switch and then after our process, if we release it, then it comes back through, because it's spring return, so it comes back. Let's see the types of it. First, 2x2 DCV. A 2x2 DCV symbol is like this. It's called 2x2 because we have two squares here, that is two switching positions, and 1 and 2 ports. Suppose you know what is this, right? I told you before, it's a single acting cylinder. It has a spring return, it has a piston, it has a rod. So in this position, this I told you this also. It's a symbol for a compressor. This provides the compressed gas. So when we attach it to the one is pressure port and this is the actuation port. So if we supply pressure through this, this T symbol indicates shut off. That is, if we supply pressure through this, as this is shut off, nothing happens here. But when we on this switch, the switch position changes to this position. So as this indicates as the air flows through this compressed gas, this cylinder gets extended. Next we have 3x2 DCV. The symbol of it is like this. We have 3 ports and 2 switching positions. In this position, we supply compressed air through this. As we have shut off here, nothing happens. Normal position, it's the normal position. But when we switch the position, then the compressed air flows and the piston moves to this end. This is operating position. Now we have 4x2 valve. We have 4 ports here and 2 switching positions. Now we can see that when it's in normal position, that is this one, we supply compressed air through this, and it moves like this, and it goes into this side of the cylinder. But here it's already extended, so nothing will happen, no more extension. But when we switch the position, the compressed air goes like this, and it goes into this cylinder. The piston was before here. As we passed compressed air, it gets extended, and we have some compressed air on this. We just have air on this side, right? That gets out through this exhaust port. This is operating position. If we see 5x2 valve, it's almost similar to 4x2, but it has 2 exhaust port, 1 pressure port, and 2 and 4 are actuation ports. Now if we see normal position, in this we supply air through this port 1, then air goes like this, compressed air, it goes like this, and here it's already in extension, so nothing happens. But when we switch the position, then the compressed air goes in this direction and it goes like this. And before, the piston was here. As we pass compressed air, it gets extended and moves to this end, and the air here gets out through this exhaust port. This is the operating position. Now one of the main questions is, why should we choose pneumatics? We have many other things, right? Like, why pneumatics? Because it's, as you saw it before, it's just so simple and easy to control and less maintenance, because it's just air. If we consider other things like electronics and all, we need more maintenance. And it's cost efficient also, because we use air which is there everywhere and free, and it's dried and free from moisture. It's safe also, because we use air, right? It's like, if we use water and all, it's rusting and all will happen, but with air it's safe, and it's suitable for long distance transmissions. But if we want high accuracy and programmable motion, then we have to use electric systems. And if we want more force, like very high levels of forces, then we can use hydraulic systems, because liquids do not absorb power, but gases do. Hydraulic systems is just, we use liquids to produce motion. Here we use gases to produce motion in pneumatics, but in hydraulics we use liquids to produce motion. That's it, guys. Thank you. And please do watch hands-on session for more understanding of DCVs.